Imagine a sort of silent, invisible tax that gets levied on, well, practically every piece of technology you touch.
Right, like an invisible weight.
Yeah, exactly.
Yeah.
Every time your favorite banking app suddenly crashes, or, the highly anticipated video game gets delayed for 6 months, or even just when your smartphone inexplicably slows down after a basic update.
You're witnessing the consequences of this hidden global
They
deficit.
really are. And industry estimates actually suggest it costs companies trillions of dollars in wasted time and delayed innovation. But the wild thing is, this deficit isn't measured in actual dollars.
No, it doesn't exist on any official balance sheet anywhere.
It's completely fabricated. It was born out of this frantic attempt by a single programmer to just appease a frustrated manager back in the 1990s.
It really is the ultimate Trojan horse of corporate vocabulary. We all just implicitly accept that building software somehow involves borrowing invisible money and paying it back.
Without ever stopping to ask why.
Exactly. We never ask why accountants don't talk about debugging their ledgers, The language of finance has just completely colonized the language of engineering.
Which is exactly why we are diving into our source material today. We have a fantastic article from the July 2026 issue of Tech Reader magazine by Aaron Rose, and it's titled, A Deep Dive on the Term Technical Debt. So, okay, let's unpack this.
Let's do it.
Our mission for this deep dive is to figure out how this one-off financial metaphor became the universal language of software development. And, more importantly, what it teaches us about how technical and non-technical people actually communicate.
Because to really see the mechanics of how this term hijacked the tech industry, we have to go back to ground zero.
Right, the origin story.
Yeah, this wasn't some abstract concept formulated in an ivory tower computer science lab. It was a desperate communication strategy during a very relatable workplace standoff.
I love this part. So the year is 1992. We're looking at a programmer named Ward Cunningham, and he's working at Wyatt Software, building this financial product called Ycash.
And he is just facing an absolute brick wall in the form of his manager.
Yeah, because the friction came from this fundamental clash in how things were built.
Yeah.
Like back in 1992, software development was completely dominated by what they called the waterfall method.
Right. And if you aren't familiar with the history, waterfall was essentially borrowed straight from physical manufacturing.
Like building a house.
Exactly like building a house. You gather all your requirements, you draw up these meticulous blueprints, you pour the concrete, and you build it. You write the code exactly once. It's a one-way street that is heavily optimized for predictability.
But Cunningham's team was kind of rebelling against that entirely. They were using this highly experimental, iterative approach.
Which was so radically different.
It was. Their philosophy was much closer to, like, sketching. You write a rough draft of the code, you see how the software behaves in the real world, you learn from those behaviors, and then you rewrite the code to be better.
But to a manager who is entirely trained in risk mitigation and strict timelines, throwing away perfectly functional code just to rewrite it sounds like absolute lunacy.
Totally. You can practically hear the conversation. The manager's like, the feature works. Why on earth are we spending 2 weeks doing it over again instead of just moving on to the next feature on the roadmap?
And Cunningham realized that explaining the nuances of software architecture just wasn't going to work. He needed a translation device.
A way to speak the manager's language.
Right. A manager who thought purely in numbers and risk. So he grabbed a concept from the manager's own world. Finance, debt, interest, principal.
And he debuted this metaphor in an experience report for the 1992 OPSLA conference. And I just think the core argument was brilliant. He basically said that shipping first-time code to get a product out the door is like taking on financial debt.
It gives you incredible speed in the short term.
Exactly.
Yeah.
And this is the critical mechanism here. If you don't pause to pay down the principal by rewriting that code later, you're going to get hit with crippling interest payments.
And those interest payments take the form of friction. Every single time you try to bolt a new feature onto a foundation that wasn't built for it, well, it takes your engineers 3 days instead of 3 hours.
That lost time is the interest. It's kind of like taking out a mortgage to buy a house today, rather than saving cash for 30 years to buy it outright.
That's a great way to look at it.
Right. Because taking on the debt isn't a mistake, it's a tool for speed. You get to live in the house immediately. The mistake is just failing to make your monthly interest payments, and then the bank forecloses on you.
And in software, foreclosure means your code base is just so tangled that development grinds to a permanent halt.
Exactly. But Cunningham made a really crucial distinction here that I think often gets lost today.
Yes, this is so important. The debt was not caused by sloppy or careless programming. The team hadn't actually written bad code.
Right. They were good engineers.
Very good engineers. What happened was that by building the first version, their mental model of the actual problem had evolved. They basically learned that the software needed to do things they couldn't have possibly predicted on day one.
So the old code was just lagging behind their new, improved understanding. The code didn't degrade, their wisdom increased.
Precisely the point.
Well, yeah.
And we really have to remember, Cunningham was operating in a linguistic vacuum here. The formal term for rewriting code to clean up its internal structure without changing what the user sees, what we now call refactoring, didn't even exist yet.
Wait, really? Refactoring wasn't a word?
Not in standard engineering vocabulary, no. That wouldn't have happened for another 3 years, around 1995. So he was inventing this language on the fly just to secure permission to do his job properly.
That is wild. And because it worked so beautifully to bridge that gap between the makers and the managers, the metaphor obviously didn't stay quarantined in that 1992 conference.
Oh, not at all.
Over the next decade, as software just began eating the world and engineering teams ballooned in size, the term basically escaped into the wild, and it started absorbing these massive, entirely new definitions.
It's a classic case of semantic drift. The real turning point was around 2003 when Martin Fowler, who is a very prominent software theorist, wrote a post on his Wiki.
His Blicky.
Yeah, it was a hybrid blog and wiki, early 2000s internet stuff. But that post dragged technical debt out of those niche academic conferences and straight into mainstream development culture.
And once it hit the mainstream, people just couldn't resist tinkering with it. They started stretching the metaphor to cover, like, every possible engineering headache.
Yeah, by 2009, Fowler introduced a very influential framework called the technical debt quadrant.
Okay, I remember reading about this.
He took Cunningham's original idea and plotted it on a 2x2 matrix. The vertical axis was deliberate versus inadvertent debt, and the horizontal axis was prudent versus reckless debt.
Which means we've already completely left Cunningham's original premise behind. Because Cunningham said debt was this honest byproduct of learning. But now we have a quadrant for reckless, deliberate debt.
Yeah.
That sounds less like a strategic mortgage, more like an engineer just maxing out a corporate credit card at a casino.
It's a great way to picture it, honestly. Reckless, deliberate debt is basically when a team knowingly writes terrible, unscalable code. Like, maybe they are just copy-pasting solutions blindly from the internet just to hit a Friday deadline with zero plan to ever go back and fix it.
Yikes. Okay, and what about the flip side?
The flip side is prudent, deliberate debt,
Right.
which is a calculated gamble. Imagine an e-commerce company writing a messy, hard-coded discount button because Black Friday starts in 12 hours.
Oh, I see.
They know it's a mess, but if they don't ship it, they lose millions in revenue. So they are taking a deliberate loan to capture market share, and they are planning to rewrite it on Monday.
Okay, that actually makes intuitive sense. But the categorization definitely didn't stop there.
Not at all. In 2007, Steve McConnell published an article in IE Software that really leaned hard into the financial mechanics. He defined the principle as the literal cost in developer hours to fix a piece of bad code.
And the interest.
The interest was the ongoing tax, the wasted time spent working around that bad code day after day. And then in the early 2010s, software engineer Philippe Christian escalated things even further by creating this sprawling 7-category taxonomy for technical debt.
7 categories. Wait, so we are moving way away from just code quality and getting deep into the weeds of the entire business now.
Exactly. He argued the industry was suffering from architecture debt, requirements debt, test debt, documentation debt, and several others.
Wait, I have to push back here for a second. Let's look at documentation debt. Because let's say a senior engineer leaves the company and they just never wrote down how the billing system works.
A classic scenario.
Right. So a new engineer joins, and instead of building new features, they have to spend 3 weeks reverse engineering the billing system just to figure out how to turn it on. I understand that those 3 weeks are the interest payment.
Yeah.
But calling a missing manual debt, hasn't this phrase just become a giant linguistic junk drawer for literally any code a developer finds annoying?
If we connect this to the bigger picture, you are vocalizing the exact crisis of meaning that struck software theorists. The metaphor expanded so much, it almost popped.
It really feels like it.
By 2020, a software architect named George Fairbanks realized the term had drifted so incredibly far from its 1992 roots that he coined a completely new phrase, technical debt.
Let me guess. Technical debt is just a desperate attempt to create a word that means what technical debt originally meant.
Technical debt. Yes, exactly. He needed a specific label for Cunningham's pure concept, that honest gap between past code and present understanding, because the original phrase had been entirely swallowed by the junk drawer usage.
You know, a piece of corporate jargon has gone completely off the rails when you have to invent a prequel word just to talk about the original idea.
It is the inevitable life cycle of a highly effective communication tool. It works, so everyone adopts it. They apply it to their specific problems, and in doing so, the term loses all its original precision.
And this massive, decades-long bloat leads us directly to a fierce debate happening in the tech industry today. According to the Tech Reader article, in 2025, modern software practitioners began aggressively debating whether the phrase has lost its actual utility altogether.
It's a huge point of contention right now.
So what does this all mean for the people actually building the apps we use every day?
Well, walk into practically any sprint planning meeting today, and technical debt is the universal excuse for friction. It's used to describe massive legacy systems like, say, big banks running on code written in the 1970s.
Wow, yeah.
It's used for outdated software dependencies, too.
Let's actually define that for a second for the listeners. An outdated dependency is kind of like building your digital house on a foundation made by a third-party company. And if that company goes out of business or stops updating the foundation, your house is suddenly structurally unsound, even though you didn't even touch your own code.
A perfect analogy. Teams also use the term for gaps in automated test coverage, or just architectural decisions from 5 years ago that simply don't fit the current business model anymore.
It's everywhere.
Right. And one camp in this 2025 debate argues this elasticity is actively harmful. By using a catch-all phrase, they say engineers are naming a feeling of discomfort without actually diagnosing the disease.
And the danger of that vagueness is totally paralyzing.
Yeah.
I mean, imagine being the executive holding the budget. Your engineering team comes in and says, hey, we have some technical debt we need to fix.
Right. What does that even mean to them?
Exactly. As a non-technical person, you have no idea what you're dealing with. Are we talking about a predatory payday loan with a 400% interest rate that is going to literally bankrupt the entire project by next Tuesday if a hacker finds the vulnerability?
More.
Or are we talking about a very manageable, low-interest car loan that we can easily pay off over the next 5 years while still driving the car? If everything is just labeled debt, you can't prioritize what to fix first.
That is the crux of the counter-argument. But the source text highlights a very resilient opposing view. Many experienced practitioners maintain that this lack of precision is actually a feature, not a bug.
A feature, how so?
They argue the term still performs its 1992 function flawlessly. It takes abstract, highly complex technical costs and entropy, and it translates them into a shared vocabulary that business stakeholders can actually reason about.
Because even if an executive doesn't know what a missing API dependency is, they intuitively understand that deferred maintenance has a compounding financial cost.
Exactly. They understand the pain of compounding interest. The phrase forces the business side to acknowledge that if they demand new features today without giving engineers time to clean up the code, the company will pay a massive financial penalty tomorrow.
So the sociological power of the metaphor simply outweighs its lack of technical precision.
Precisely.
It's a fascinating compromise.
But just as the human beings in the industry are kind of settling into this uneasy truce over the definition, an entirely new non-human method of writing code has arrived on the scene.
Oh, yes.
And it is testing the absolute breaking point of Cunningham's financial metaphor.
We are, of course, talking about the explosion of AI coding assistants.
Right. Artificial intelligence is no longer just a parlor trick. It is generating a massive, growing percentage of the world's code base. And the Tech Reader article highlights some really groundbreaking early research from organizations like Pharos AI and CodeScene.
Yes, they've been doing some fascinating work. They've been analyzing repositories of AI-generated code, and they found that the mechanics of how this code accrues debt are wildly different from human-written code.
The defining metric they've uncovered is called churn. AI-generated code exhibits a staggeringly high churn rate relative to its structural complexity.
Meaning what, exactly?
Churn just means the code is constantly being added, modified, ripped out, and replaced at hyperspeed.
Which makes sense mechanically when you think about how developers actually use these AI tools. Like, human types a prompt. The AI instantly spits out a block of code.
Right.
The code looks plausible, but it lacks the broader context of the entire software architecture, so there's a subtle bug. The human spots the bug, tweaks the prompt, and the AI just overwrites the whole block with a new, slightly different guess.
It is high-velocity trial and error.
But wait, this reveals a massive contradiction in the metaphor, doesn't it?
Let's hear it.
Okay, so Cunningham's original pure idea of technical debt relied entirely on a human programmer's evolving understanding of a problem over time. The debt was the gap between what you knew yesterday and what you know today.
Correct.
So how does that apply to an AI? An AI model is fixed. A large language model doesn't have a mental model. It doesn't learn along with a team over a 6-month project. It doesn't have epiphanies about the client's needs while taking a shower.
It really doesn't.
It is just a statistical prediction engine, guessing the next line of code based on patterns. It just spits out a plausible solution.
This raises an important question, and honestly, it is the bleeding edge of software theory right now. Are we taking a metaphor designed for a deliberate human borrower and applying it to an entity that has absolutely no intentions at all?
It's kind of like applying the mechanics of a financial mortgage to a swarm of termites building a mound.
Oh, that's good.
Right. The termites aren't taking out a loan to build faster. They are just reacting instantly to their environment. If there's no intentional borrower, can you actually call it a debt?
It is a phenomenal analogy. And the consensus in the research right now seems to be split. The fundamental truth still holds up. If an AI generates a flawed piece of code and you build the rest of your application on top of it, you will absolutely pay a brutal interest rate and debugging time later.
So the deferred cost is very real. The interest payments still exist.
The interest payments are inescapable, regardless of who or what writes the code. But the principle, the origin of the loan, is totally alien. The AI isn't learning, it is just hallucinating solutions.
Wow.
So the field is actively grappling with whether the technical debt metaphor helps us manage AI code, or if it's just being stretched to its absolute breaking point, giving us a false sense of security by making something deeply unpredictable look like a standard spreadsheet problem.
It's just staggering to step back and look at the trajectory here. 30 years ago, Ward Cunningham was literally just trying to get his boss to let him clean up some Ycash code.
That was it.
And today, his makeshift financial metaphor is being used to analyze the output of neural networks that write code at speeds humans can barely even comprehend.
It really proves the longevity of a truly great piece of borrowed language. Technical debt survived the transition from the rigid waterfall era to modern agile development.
It survived the chaotic scaling of the internet boom, too.
Exactly. Transforming from a specific explanation about iterative learning into a massive, sprawling catch-all for deferred maintenance. And now it is fighting to survive the AI revolution.
Because underneath all those Fowler matrices and Cruchton taxonomies, its core function has never changed. It makes the invisible, highly abstract trade-offs of software engineering legible and real to the people who hold the purse strings.
It is a bridge between two worlds that fundamentally think differently.
And in software, securing that shared vocabulary between engineering and business is frequently the single biggest hurdle to success. I mean, the code is often the easy part. Agreeing on reality is the real challenge.
That is the truth.
It does make you wonder about the next 30 years, though. We've spent decades borrowing the vocabulary of accountants to explain the digital world.
We have.
But if AI fundamentally changes how code is constructed, if code is no longer being built like a house, but is instead mutating and generating at speeds humans can't track, maybe finance is just the wrong field to borrow from entirely.
That's a really interesting point.
Right. Perhaps we are approaching a horizon where we have to abandon the ledgers altogether. To explain how our software grows in the future, we might need to stop talking about paying down interest and start borrowing language from biology or physics.
Like studying an organism.
Exactly. We might find ourselves talking about pruning overgrowth, managing mutations, or containing invasive species in our code bases. So keep an eye on the language in your next stand-up meeting. The metaphors are shifting beneath our feet.